This is the video for 12-2 pyramids. Okay, all right, so this is the warm-up. This here, there's nothing new here, but it's a very important concept for this section. Okay, so this is a pyramid. Okay, and so you have a square as a base. Okay, and then these sides are all isosceles triangles. Okay, it's all same length. And because the square has 4 same lengths, these 4 triangles are congruent triangles. Okay, and we are getting the total area and volume of the pyramid in this section, but to do that, you need to get this length and this length. So on this warm-up, we just focus on getting those lengths. Okay, so first you got this length is 13 and this length is 5, right? And this is 90 degrees. So if you look at this triangle, that's a right triangle, right? So then L should be 12 because this is 5, 12, 13, Pythagorean triple, okay? And now we know that this is 12 and this is another right triangle right here. You can use the Pythagorean theorem to get H. So now this is hypotenuse. So don't make this a 13 because this is shorter than the hypotenuse, right? So you have to do 144 minus 25 is 119. So H square is 119, then H is square root of 119, okay? A lot of problems are like that. They just give you this length, which is called slant edge. We're gonna go over the vocabulary right now. It's called slant edge, and you have to get the L and H. In that case, it will give you this length and then this length, and it's not gonna even give you 2 5s, or they just put 10 0, and then you are supposed to know that this is gonna be 5.5 5. Okay, and also if this is 10, this length is 5, so they are not gonna even give you this. Okay, you just get 10 and 13, and you're supposed to find out the L and H and so forth. Okay, but with practice, it will come very easily to you, I hope. Okay, so here is the objective. Identify the parts of pyramids and find the lateral area, total area, and the volume of right pyramid. And you know, in 12.1 this was prisms, okay, and now it's a pyramids. That's the difference. Okay, all right, so here's the vocabulary. Okay, so the perpendicular distance from the vertex to the base is the height or the altitude. It's interchangeably used, but whenever it's h, it's the perpendicular distance from the vertex to the base. Perpendicular distance from the vertex to the base. Okay, that's a h. These side of the pyramid are called lateral face. Okay, and these edges of the pyramid, where the 2 lateral faces meet, is called the lateral edge. Okay, and this length right here, the one that on the warm-up, this length, which is the height of this lateral face triangle, isosceles triangle, this length is called slant height. It's called slant height to distinguish from the lateral edge. So if I just copy this one lateral face, this is isosceles triangle, this is the slant height, and this is lateral edge. Okay, and slant height is usually expressed with L. Okay, so this is what we just did in the warm-up. And another thing to know, when they say regular pyramid, that means the base is a regular polygon. So if it's regular hexagonal pyramid, then the base of the pyramid is regular hexagon. If regular quadrilateral pyramid, then the base is a square. If it's regular triangular pyramid, then the base is equilateral triangle. Okay, And the side of the pyramids are always isosceles. These are all congruent lengths. The lateral edges are all congruent. Okay? So when you say regular pyramid, that's what it means. The base is regular. This is no regular pyramid because this is not a regular pentagon. Okay. And here are the formulas. Okay, so let's just go back here. To get the lateral area of this hexagonal pyramid, first you have to get the area of hexagon, right? And you know how to do that from chapter 11. And then you get the one area of a triangle. You can do that by knowing the length of the side and the slant height, right? Slant height, base times height times 1/2 times 6 would give you the total area of this pyramid, right? So that's this. This is 1/2 of base times the slant height will give you one triangle, and you multiply that by number of the side of the base, you get the lateral area. And the lateral area plus the base area is a total area. But this will give you the lateral area, right? One triangle times number of triangle. But since these are all multiplying, you can change the order, and you can get 1/2 of NB times the slant height. Now, N is number of side, and B is the length of the base. So this is a perimeter, right? If you do, this is B, and then you have N size, then the perimeter is gonna be NB. That's why this formula, 1/2 of perimeter times the slant height, comes up. Okay? All right, and so that's this theorem right here. Okay? And then for the volume, this is a prism with a base area of capital B, distinguished from the small b. This is the length of the side, base, length of the base. The capital B is the area. Okay? So capital B times height will give you the volume, right? That's from the 12:1. For the pyramid with the same base and the same height, the volume is 1/3 of this. Okay, and in ACP classes, I often bring these transparent polygon-shaped cups, and then I scoop the rice grains with the pyramid and put it in the prism, and see that actually I can put the 3 scoops in the pyramid, because the feeling is that this volume feels like more than 1/3 of this, right? But it's actually only 1/3 fits in there because very little fits in here, right? And the part that is not there is actually twice as much as the part that is in here. Okay, so just to remember, if you know the volume of the pyramid, you know the volume of the, the volume of the prism, you know the volume of the pyramid because you just have to make it 1/3. Okay, and that's this theorem right here. The volume is 1/3 of base area, the capital B, times height. Okay, so there's one more thing I need to show, which I think this was in chapter 6 that we skipped. Here it says, here, the AM, where is it? Here, AO is 2/3 of AM. AO is 2/3, this is 2/3 of AM. So this is 2/3 of this whole thing. And then it says Y here. And you don't know why because you haven't learned this. So this is what I have to show you. No matter what kind of shape of triangle it is, I scale in, right triangle, obtuse triangle, whatever. If you do 3 medians of each vertices, those 3 lines, okay, so these are 3 medians, those 3 lines always intersect at one point. Okay, and this is called centroid of a triangle. And through the centroid, the ratio of these 2 segments that is cut off of this median is always 2 to 1. From the vertex to the centroid is 2, vertex to the side is 1. It always is. This is 2 to 1. This is 2 to 1. Okay, so if you look at the top portion to the whole that's 2 to 3. This is 2 to 3. This is 2 to 3. And for the same token, this is 1 to 3. This is 1 to 3. This is 1 to 3. And this center is called the centroid. But you don't need to know that. I'm just telling you what it's called. Okay? So in this diagram right here, this point O is a centroid. And it's actually other kind of, this is in center and ortho center because it's equilateral triangle. All those intersection is going to match up here. But for the purpose of this, this is equilateral triangle. So if you do a perpendicular line to the base, this bisects it, right? So this becomes a median. And the vertex, the altitude of the pyramid from the vertex to the base at perpendicular, it goes down to the centroid. So this distance is 2 to 1. So AM is 3, then AO is 2. This is 2 to 3. That's what this is. Okay. So I want you to read through this and understand. Okay. You can read this too, but you know how to get these, so that shouldn't be a problem. And these are the exercises, so I think it's good to do maybe odds here. Okay. So do odds, and I think this is following the 3 steps to sketch a square pyramid. Okay, so this is like a instruction how to sketch a pyramid. You can try it. Here it looks like you can see the 3 sides, but I don't think that's possible. I don't know. I would do like this. I draw 2 sides, right? 2 sides, because usually you can see 2 sides, and then I draw vertex, and then bring down the 3 sides, and then, or maybe you can see the third side, and then like that, and bring down like that. Okay, I guess that's kind of same. Okay, do odds here too, homework. Okay, regular triangular pyramid with a base 4 and the sun height of 6. Regular square pyramid with base edge 12 and lateral edge of. Alright, so maybe we do this one in video, the 7 together. Okay, so regular triangular pyramid means the base is equilateral triangle. So you have equilateral triangle and you have a vertex, and you come down here like this, and actually these 2 lines should have been dotted. This is dotted, this is dotted. Okay, all right, and base edge of 4 and slant height of 6. This is 6. Okay, and you have to get find the lateral area. Okay, so lateral area is just 3 times this, right? So you get the area of this and times 3, or you can do the perimeter times times the sun height times 1/2. Okay, so the lateral area is the area of triangle is half of the base times the height, so that's 2 times 6, that's 12, times 3 is 36, or lateral area is 1/2 of perimeter times the sun height, so it's 1/2 of the perimeter is 12 times the sun height is 6, so this will give you 6, and this is 36. Unit square, unit square. Okay, you do 9, and the rest we can do in class. Okay, already.